Well, grab your pizza while it's there and get ready for part two, the peace part of War and Peace, which also promises to be very interesting and very different to what we normally see in data science. I mean, what do we normally see? We see service industries for the most part, maybe retail. We don't see a lot of warfare, and we don't see a lot of agriculture either. Kenneth Sabir, or Kenny as I know him, well, he gave me a rather long bio, actually. So I'll just pick out the highlights, and there are some amazing highlights here, of course. So first of all, he was the first employee of Agriweb, the organization that you're going to hear about, where he's been for 8 years, where he's been leading the technical design and engineering team as the head of engineering, who support 14,000 livestock producers with 60 million livestock across 65 million hectares across the globe. This is probably in your presentation, isn't it? And he's moved to the new role as a VP of R&D last year. He has in the past delivered leading edge software products for top tier research and development companies, including IBM, Bell Labs, Cyro, and Canon Research. So he has a passion and extensive experience in technical leadership and complex problem solving. He was the bioinformatics architect at the Garvan Institute of Medical Research. So there's a whole other side to him of doing bioinformatics to PhD level. So he did his PhD in visual analytics of macromolecular structure in 2019. He worked at IBM for 8 years, including 2 years with IBM Research, using bio-inspired computing techniques for steam processing. Holds 14 patents filed and 8 peer-reviewed research papers across diverse fields as database design, data visualization techniques, stream processing. I think that you meant stream processing before it said steam processing. Text mining, bio-inspired computing, and bioinformatics. Please take it away, Kenny.
I'm excited by that new field of steam processing. To make something of that. I'd like to acknowledge the Gadigal people of the Eora Nation and pay respects to their elders, past, present, and emerging. They've been looking after this land in a sustainable way for tens of thousands of years, and that's something that we're all striving to do now, especially in our research. So today I'll cover a few points. When I was mentioning my PhD topic, you just said, talk about that as well. And I tried throwing in one slide and it wouldn't make any sense. It would just been a bunch of random words. So I had to throw in a few more slides. So I'm going to have to hoon through these to get to the other stuff. I'm just going to talk a little bit about Agriweb and talk about what it is and how we collected all this data. And then ForageCast, this large research project that has started that is using this data. Okay, so the previous work. So above was the companies I worked and below were the products that came out of it. Working with IBM Research, I got involved in a topic called embryonic stream processing using morphogenesis. That's the end of that. See, it made no sense at all. So this all came out of September 11, actually, when the NSA was formed and was, how do we analyze all this data? You know, what later everyone knows as the Echelon project, and they approached IBM and they said, there's so much information on the internet, there's too much, we can't store it all, we just need to know what's the important stuff. And then at that same time, there was research coming out in the early days called stream processing. And that is, normally we just say all the data in the database and you throw queries against it. And stream processing was looking at how do you get data to act like a data flow diagram where the data just keeps on coming through. And you can put all sorts of filters, windows, whatever you want to be able to figure out what's the useful stuff. So all these different nodes coming from the data flow diagram that could exist on different processes. If anyone's a programmer here and has played with RxJS, so any of the reactive languages there, It's like that, but 20 years earlier, where each of these streams of information can exist on different computers. And stream processing was connecting all the dots together to pass information between. And they invented languages as well at the time to support this. So this is narrowing down to where my problem was. And stream processing, it's typically done where you allocate all those different roles to say, hey, you computer over there, you do role A, pass information to you computer over there, role B, like that. And you keep on centralized way of allocating the roles. So there's many problems with centralized architecture. There's points of failure. You can have finite scalability. There's going to be bottlenecks, etc. So can the role allocation for streams be distributed? And that brought me to this guy. So I got inspiration from Alan Turing and the zebra. So a month before Alan was arrested for being gay, he came up with this paper that completely revolutionized and made up this new field. It was called The Chemical Basis of Morphogenesis, and it merged physics, chemistry, and biology together. He was fascinated by how does a human zygote, a single cell we all come from, how does it split and split and split? And then one side knows to become a head, another side knows to become a tail. Every cell's autonomous, yet somehow they all communicate and they coordinate. You don't get like a bit of tail out of your head. They're all coordinated and you get all the heads together. So he didn't have, well, he had his computers, but he was just like at home and he had like notebooks. So he came up with these equations of decaying gradients that he called morphogens. And then he could plot them out on his grid paper. And he came up with equations of you just decay at different rates and you get these repeating patterns coming out. And then that's how he thought like how the cow patterns were working. And later on, they tweaked them and got the zebra patterns and so on. And then that's using like in developmental biology. And then 10 years later, someone found out a link that this is actually happening. You can actually reproduce this experiment using chemicals as well. So what would distributed role allocation give us? I'm already going too slow. Imagine like thousands of sensors. Now you don't need a centralized computer to be able to tell them to do complicated problem solving. They can all differentiate into different roles, and you wipe out half of them, they can reorganize. Other examples. So this research is blending in 3 different areas of research. So there's stream programming at the top. There's this idea that if we call all the different roles possible, that data flow diagram, if you call that a genome, every node has the concept of that, what's possible, it differentiates into the right one at the right time. This was already a particular area of science called embryonics. And then I was bringing in morphogenesis, and that's the Turing's work on the differentiating gradients. And there was some simulations done that shows the role in the bottom left and then distributed nodes and how they differentiate in the top left. And there's efficiency ones and so on. And look how young I was when I did this. So young that I thought 3D graphs was a good idea. Anyway, so this was showing you, they realized that efficiency, it would be very rapid. You just see all of them with like a random amount of morphogens between the different gradients, and very rapidly, just like in normal development, they can figure out which side to go on. All right, that's topic number 1. Just steaming through the research areas in Sydney and IBM that got closed down for political reasons, and IBM in Melbourne started up. They had all the I had all the patents in there, couldn't take it anywhere else. Started my PhD again. Instead of using biology to help computers, I started using computers to help biology at the Garvan Institute. All right, and just very quickly, in the bottom left, you see Aquaria. That's this software we did. We looked at the hundreds of thousands of protein structures against the millions of protein sequences that no one knew what the structure was. This is a while back, 2012. So what we're doing was a homology mapper where we could mash them all up and then say, for this unknown sequence, you don't know what it looks like, but you know the letters. We can say the start of it looks like this structure, the end of it looks like this structure. Here's some other 50 structures that are very similar. Here's some other 50 sequences that are very similar. And it was a browser that you could go through and drill in, and it was a tool for the biologists. And then I was interested in the visual analytics and proteins, like, you know, there's a whole lot of data there. That's pretty exciting. When you move to chromosomes, then you're talking much more exciting data. You're talking 3 billion bits of information in every cell in your body, made up of all these chromosomes. Now, how does your heart cell differ from your cell, your toenail cell versus your heart versus your kidney cell? They all have the same DNA. How do they know what to do? So this research came out in early 2000s, where they found out that the structure of how the chromosomes are folded, they were actually suppressing the genes from working just because it gets tied up in a knot. So the structure was very important, and they've been doing experiments where they could determine that. So you got your 3 billion bits of DNA broken up into a few chromosomes. What they do is basically put it in glue, break into little pieces, then resequence it. They go, oh, a little bit of chromosome 1's touching a little bit of chromosome 12, like that, and you come up with this massive contact matrix. So I was looking at visualizing that. And the idea was, the hypothesis was, imagine you could look at all the areas in a cell, a particular cell, that's in close location. Let's throw them against other databases to find what do these genes have in common. Maybe they're all related to breast cancer, for example. Or like in the top middle of there, you can see I'm comparing the same area between normal and cancer. And for this, one of the areas we worked on was looking at this Martini database. This is some German partners we were working with. And they went through every research paper from 1970, and they did keyword analysis in every single word. This is still a long time ago, but is it each word? Is this a protein? Is it chemical? Is it a disease? Is it a gene? Is it even a Wikipedia term? Then they went through, and then for every research paper, you have the ID to all these different taxonomies of what's possible for it. So from there, we could throw that against our 3D database and go, oh, it's got these genes. Oh, look, breast cancer is overrepresented in the papers that came out of are related to those genes. Okay, now to the next part, which is not even the main part. Agriweb, the product overview. So this is the question, that the problems that we're facing. How do we feed more people, 10 billion people, without using more land while lowering emissions? So the purpose was to empower the livestock industry with the best tools to feed the world sustainably, profitably, and efficiently. Like there's not going to be a silver bullet. We all have to attack the supply chain and the protein supply chain at all different parts, and we've chosen livestock. Agriculture was, left behind in the technology revolution, the knowledge revolution. Within agriculture, livestock was far behind as well. Even in cropping, they had GPS riding tractors for 20 years. So we started in 2014, quite a company in 2018, got offices here and there, salespeople in Denver in 2020. And some of the numbers that you just heard before, 60 million animals through the system. And this is what we're replacing. So the farmers, they do love their data, especially in Australia, where they don't survive on their farming subsidies. So here, they've been collecting the data for a long time, and this is how they do it. And this is how they do their succession planning. This is how they look back to understand what did they do in this weather scenario last time. You might have 80 paddocks, 20 mobs of animals. When we're going to move them next? Somewhere you got to write out, when was the last time you moved them into paddocks. So we're digitizing at that level, we're at the source. And this is the world we came into. Everyone needed this data, from your accountant to the processes, the regulatory bodies, and it's all getting passed around through emails and spreadsheets and phone calls and shoeboxes of receipts. And this is the beautiful symmetrical diagram that makes everything better. And the benefits of the digital ecosystem. And so there's many different areas, that we cover: the animal management, the pasture management, the business management as well. And we're about 25% of all the livestock in Australia. All right, so how did we get people to enter in the information? First, we had to make it a holistic platform. So we had to cover all the different records that are happening on farm. We had to make it an intuitive visual interface so they'll actually use it and see the benefit. That's like simple, like, drag and drop a mob on your paddock. And in Australia, the regional areas, they suck for connectivity. So we had to make it work offline, and then we'll automatically sync when you come back to home. handling multiple users and sync conflicts and all the fun technical problems that come with that. And we started 8 years ago as a mob-based product. You say, I got 50 animals here, the average weight is this, that's fine, it's very easy. 2 years ago, we added an individual animal-based product. So now we hook into all the hardware that's in the farms for RFID scanning of the ear tags. Comes in, we hook into the weigh machines, so you get individual weights and so on. So in other words, you've got heaps of data. And we also released a supply chain product as well. So now you can have hundreds of Agriweb farms all managed together as they go through your different stages. And the marketplace. So the marketplace allows you to we integrate with all the different third parties on board, and that's also adding to our avalanche of data. So like this is an example of the satellite-based pasture monitoring, where you can hook in and then every 5 days, the satellites will tell you how much feed on offer there is for the animals. So now as you move, you drag and drop your mobs across, you go, hey, you got 30 days left before you're overgrazing. And then, that's dangerous for the sustainability of and the resilience of your farm. So it's a good time to move them. We also integrate with all the other IoT devices, like the water sensors and the rainfall and water tank sensors. All right, as I mentioned, 37% of the world rural areas have access to the internet worldwide. So there's many interesting technical challenges in this space. So farmers, we have to be able to support backlining, offline support. Allow the farmers to view their farm at any point in time and support the multiple users with the sync conflicts. So how do you do it? How do you say, the animal weighs this much, that means the paddock grass is this much, move these other animals in. Oh no, actually, I moved these other animals out like 2 weeks ago. All the numbers downstream have to change. So the idea was event sourcing. And this is not a new problem. A lot of you guys might be working in this space already. Banks do it, but it's basically like where the important information isn't the end result, but it's the series of events that get there. So that becomes the source of truth. Your bank statement, if you withdraw $200, the bank doesn't care about your latest result. It cares about saving minus $200. So it can add up to figure out what your total is. So we use that to make a time machine for the farm data. So you can basically go back at any point in time and see the state of the farm. And it works offline. So this is programmers in here, Martin Fowler. He was promoting the event sourcing many years ago as well. And just this seems a bit programmy, but it's going to be relevant as well. We use this CQRS, command query responsibility segregation, where it's basically two separate systems for writing the data versus reading it. Now data, now you're getting excited. Snowflake, right? Some smiles. All right, so basically this is how our data gets to Snowflake in small font. We can have all these rules that are based on these events. These are kinesis streams. So the data can, all the data can flow through the kinesis streams. We can have synchronous rules. So like when you save your animal, you might want to see the data straight away. Or we can have asynchronous ones. Maybe it's generating some report in the background, and that will just read it off the kinesis stream. In the end, it will throw these, what we call the aggregates, which is basically the data that the user cares about. The user doesn't care about the events. Throw the aggregates onto the kinesis bus, goes to kinesis firehose, goes to S3, goes to Snowflake, and gets to Snowflake. All right, Progecaster. So as I mentioned, Eugene mentioned 2 years ago, I realized we had a hole. We've done a whole lot of work on collecting all the data, all the actuals of what was happening on farm, but we did very little to use that on planning. Agriculture research is a very important thing in Australia, yet we didn't have much interaction with all the research going on. So we started up a new R&D group at the company where we can liaise with all these different groups to try and bring some of this research to the thousands of producers. So the current situation is we're getting the progressive farmers plus a lot of the corporate farms that really want to know what are the sustainability metrics. How much is getting sequestered by their vegetation and how much is getting emitted by their cattle. From the farmer's point of view, they need to know when are my animals ready to sell? How do you forecast the weight over the next few months? There's been a lot of developments in weather forecasting as well. This is something that's improving year upon year. Now, it doesn't have to give you a crystal ball, because as we know, that's never right. But what it does give is a probabilistic output of a seasonal forecast. Once you get all those different numbers, we could run through all the different simulations. So we could show the farmer what's the effect of their farm in wet weather and dry weather, and they can make plans for that. So the sustainability is a very important thing right now, as we're seeing all these different pressures are coming and they're building, both from the investor, the consumer, and the regulatory pressures to be able to handle the Scope 3 emissions. And then for that, each of these supply chains, and these are all the largest companies in the world, well, for food, they need to be able to track all the way up the supply chain where all the impact of emissions. No one has this data, right? Because no one has been capturing it at the source. Everyone's just been guessing at the macro scale. And there's all these regulatory pressures coming in now that are, forcing people to do this. Imagine we could do this, and there are basic algorithms for this. We could give you a sustainability metric right now. The next question is going to be, oh, I know I'm buying animals in 2 months. What do we have to do now to be able to hit our targets in 6 months for sustainability? So the idea is to create a livestock supply forecaster using the best of breed domain models together with machine learning. And this is using the weather forecasts to understand the probabilistic output of the pasture growth, to understand the probabilistic output of the livestock growth. With that, you'll get an idea of the sustainability metrics. And also another area we're looking at is how to deal with the resilience, improve resilience on farm. That's what I said in words. But what I take your eyes to is on the right, and that is the grazing planner. That's going to be one of the outputs of this project, one that takes the future weather into account. So you can make up your grazing plan for wet weather and for dry weather. And we'll be able to get the livestock availability at sale, and also aggregated sustainability metrics, both for the farm and also for the enterprise corporate farms. And it ended up being a big project. If you're familiar with CRCs, that's what the government invented to try and help industry adopt research. It means that there's a three-way partnership. Industry puts in money, government puts in money, academia puts in money. 75% goes back to research, 25% goes back to industry to implement it. I've given all the pictures of the researchers. I ran out of room for the industry and government people, but there's lots of people going on. We've got UTS, QUT, Agriweb, Flint Pro, SIBO Labs, MLA, Meat and Livestock Australia are going to be coming on board, but we're still in the contract stage, but they'll be coming on board in Q4. And the New South Wales DPI as well. So we had to break this up. It's a very big problem, and there's a whole lot of postdocs to make use of. So we've got 4 major streams. We've got a pasture stream, a livestock stream, the sustainability metrics, and the planning tools. There'll be a lot of detail of this coming up, but this is one of the fun bits of this project is we're working with multiple industry partners, and we can't be corrupting our privacy agreements. So we had to work with a whole lot of containerizations where the industry partners can give us their algorithms, put it in a container, and then we could run it. We've had to encrypt all IDs and so on. But yeah, it's a lot of playing in Snowflake. But yeah, that's what the researchers are using directly. And this is like what the kind of benchmark looks like. Grazing planner, other bits. All right, so you want to see some more details. This is like what SIBO Labs can do. They've been doing this analysis to be able to find out the pasture for all of Australia, for every farm. It's at a coarse resolution, but it's covering like every farm in Australia. So if they want to get the high res, then they pay for the integration with Agriweb, and then you get it down to the paddock scale. So we're bringing them on to be able to run this same thing, but for the last 5 to 7 years across all of our Agriweb farms. So we'll get a historic view of all the feed on offer that's happened. but they'd love to work out what the pasture growth rates are, but they'll be missing this one key ingredient, which is us, because we know where the animals were. So to really understand how much grown, even from satellite, you have to know what was in there eating it down. Once you know that, then you know how much is getting sequestered from the atmosphere, and then that's coming into the sustainability metrics that people are caring about. One of the problems with SIBO at the moment, it does a really good job at capturing the quantity, but it doesn't do a good job at capturing the quality of it. It's like the animals could be eating heaps and not putting on any weight. It's like we think of it as junk food and that it's bad, but it's opposite of junk food because you're not putting on weight. So we need to understand what the quality of the pasture is. So we've got these like test farms that we're going around, and we're flying drones around. And the whole idea is we're using the drones to look at all the what they call Sentinel-2, the satellite imagery, and there's multiple layers. And we want to be able to tell, can the drones help us look at the satellite imagery to work out quality? And yes, that's pretty. There's too many slides. Okay, there's correlations there. This is from the testing we've been doing under the Molong area. All right, so that's one area. And then QUT, they're working on the pure machine learning part of the feed on offer. So at the moment, they've started looking at all the weather characteristics to work out what the food that's feed on offer out there. So they've got this many dimensions, some dimension reduction, bringing it down from like 80 something to like 11 to make it more usable. We're throwing in other data sets here as well, like different vegetation classes from different sources, and we're looking at all the different grass types as well. Okay, so and this is they're looking at neural networks and the deep neural networks as well, and they've been trying different approaches on playing on how much time lag they're looking at for like rainfall and so on to see what's working the best. It's a time lagging. Okay, there we go. Livestock stream. We're currently here. We've done a whole lot of data exploration. So there's a whole lot of features that you could look at for figuring out livestock growth. The most basic is like the characteristics. It's species, its breed, its sex, how old it is. And then there's all these other criteria that could affect its weight. And we're focusing on the left for starters. So here we have like categorical encoders, the time-sensitive encoders, and sequencing encoders. We also have biophysical models, like because this has been research, it's been that people have been coming up with algorithms for years for this. So we're going to be feeding these biophysical models as well, and to try and say, what do you reckon it's going to grow? Old researchers, and feed it all to the machine learning, just to see if that's going to give it a boost. And so many animations. All right. A lot of these slides, so all those pretty faces I had on that team shot, they're the ones that are credited with making these slides, and I'm just reading them out. So we have multi-level, multi-layer perceptron, and then recurrent neural networks and the convoluent neural networks and attenuation networks. So there's many different layers that we're capturing there. The important thing about this is it's time series data. So, we have to take that into account. And it's tricky. Every time we talk to them, we go, you're just looking at whether the paddock has livestock in it at that very second. No, you got to think about, they might have just moved out 5 minutes before. You have to take all that into account when you're trying to calculate this pasture growth, but we're getting there. And this was a very initial time when we started looking at what does the data look like, and it looks like very fat, and it's user-entered data all over the place. Looking at the histogram, you can see that there's so much entries when they're young, then no one really cares over here, especially for the males. They've all been sold off by here. And we're looking at this and, well, what are we going to do with this mess? But then when we started throwing it in to box plots, see, oh, the standard deviation actually looks quite tight. And this is still just looking at the characteristics. We haven't started to take into account it's whether it's been castrated, whether it's had treatments, its location, rainfall, any of that. And we don't just do cattle, this is sheep as well. You can see it goes a bit haywire here because no one's keeping male sheep after this age. All right, another interesting thing is bias. As I said, we have individual and mob data. So how do mob people make up their weight? If you look at them and you go, I reckon that's 600 kilograms, so 550. And if I jump back to one of these slides, if you look at these like little artifacts here of the vertical horizontal lines, that's all the mob data people guesstimating, 550, 600. So we've got another research group looking at data quality throughout the whole project, and they're trying to figure out the bias of a mob value. So there's two parts. One is to figure out the error for that mob, because if you have individuals and you treated them all the same, you might get a standard deviation of 20 or something like that. If you have a mob, we just have one number, like 580 kilograms, all right? So what is the standard deviation? First up, we're trying to figure out what is the bias. Are people overestimating or underestimating mobs? And does it change at different times? And then the second part, once you work out that bias, is how do we give the mob data standard deviations? Sustainability, I'll go super fast. This is the Flint Pro. So this is our industry partner that's being able to look at any of these different areas and work out through the satellite imagery, the above ground carbon. There's been a lot of problems with carbon sequestration in the past where people aren't using these proper research techniques, and they're just signing some papers and guesstimating, and then people do an audit and they realize, oh, there's broken down cars in that paddock, and you're treating it as a rubbish tip. So satellite imagery is a surefire way of being able to do it in a scientific manner. All right, so the carbon calculations are pretty straightforward. We could do them now. Soil carbon is a lot more complicated, but we're looking at vegetation carbon and emissions. So what we want to do is look at the New South Wales drought. All the farmers that bounced back from there, the ones that did better, that bounced back quicker, what did they have in common? So did they have better biodiversity, better, more diverse pasture species? Did they sell earlier? What's the criteria that we can find to help the farmers become more resilient? So this is an idea of the success of a farm. And then this is the drought happening. Everyone's losing money. So what's the cost of this and how do you minimize that? Okay, so some different options here. You can have, high baseline productivity and high resistance. That's the ideal, I guess. It's not bad too, but yeah. And then, so how do you categorize all this? What do we actually do to say, what are we looking for? What is there to improve? NC is a natural capital. So there's many different areas we're looking at, and looking at the different themes, we're going to focus in biodiversity for starters. Finally, another slide or two, and this is for the simulation. For the planning tools, there's two parts, the simulation and the design. The simulation, we're looking at all the different user requests, the different objectives you're trying to maximize, the different constraints, the farm state you have to deal with, and what's the models you get at the end. And we're also working with UTS Design, and they've been doing over 30 hours of interviews with the farmers. So working out the real requirements, working out how do they do planning currently. And then we're starting to throw wireframes at them as well. Does this make sense? Does this make sense? So this is some examples of what the grazing planner could look like. All right, I'll breathe.
There'll be a lot of questions. First,
Are we going to get the deck? Deck?
Deck, sorry.
are you going to
Slides.
find the slides?
Oh, yeah, sure.
Do your slides have your contact details in case people want to ask more questions?
Probably not. Kenny.Sabir@Agriweb. If you remember that.
We'll pass that along in the comments to the group. By the way, do you want to make your slides available to us there? Okay,
I'll kick it off.
So as someone who's come from a weather background, I mean, you glossed over everything very quickly because you had to get through everything. But yeah, so the weather data you used, they just like long range outputs, long range forecasts from the Weather Bureau, or what were they?
Yeah, so there's a few different ones. One of the exciting ones that is coming onto the markets in recent years is the seasonal forecast, and that's the 6-month ones. So we're looking at various commercial providers, and we're talking with the BOM as well, the Bureau now. They've had one called Access S1, but they've recently released Access S2. So S1 is available easily. S2 we've got to pay for. The commercial ones, there's a few different providers we've been looking at. We did a evaluation last year where we looked at regional Australia and all of our IoT weather data, and we said, so what do you guys think it is historically? Because no one's got a weather sensor in every paddock in Australia, so no one really knows. Everyone's doing their best guess. So we could compare that to the actuals of what we actually collected, well, farmers. And yeah, we did an evaluation on that. Then we also looked at their forecast models and ran them through hindcasts as well. So what did your forecast say it was back in 2019? Hopefully they're telling us the truth, but
I used to work for the Bureau. I know what they were like.
we were playing with the Access S2, the hindcast of 2010, 2018. But unfortunately, most of our sensors came on board in 2020, really, it started. So we couldn't actually use that S2 forecast hindcast.
Thanks for the talk. I have a question. I might have missed it, but you guys work with like image data directly, right, from the satellites, or you working from third-party vendors that analyze that for you, and then you guys get a data from there? And my second question is related to: are you looking at options where you guys can deploy your own kind of hardware, like drones and sensors, to collect more data to have them more high? Just two-part question.
Yeah, it's an interesting question. Like we are working with multiple third parties that do satellite imagery. So there's SIBO Labs in Australia, there's Regrow in the States. There's another one I forgot, sorry. So they do a lot of the processing already, and we can give the paddock boundary and they'll spit out a number for us. Saying that, we've also done prototypes with SIBO where we actually get their images and bring it back into the system. We also we used to have resources in the system for people can take photos. So we're going to re-add that again. And there's going to be a whole lot of interesting area for machine learning on pasture photos. So just because of the number of photos we'll be able to collect, can we throw them into a stable diffusion kind of thing and get it to spit out, take a photo, it automatically identify both the height and also the pasture types.
Just thinking about the first presentation we had, and we we're talking about the morale of the troops. Do you do anything about the morale of the farmers or the morale of the animals?
Interesting. So the farmers, there are a wide range of farmers. A lot of our customers tend to be, the ones that really care about the data. And it works well in Australia because it is quite a competitive market, and they're all quite serious about farming, and they do love farming. Compared to like the US, it's a lot harder to break in there because they're a lot smaller for one, because of all the subsidies. So it's like Australia maybe 8 years ago, not regarding size, but regarding adoption of technology. People aren't thinking, why would I need an app for this? what's the purpose of data collection? Why would I want to improve my business when I can be a cowboy? Yeah. So so it is a wide range of farmers that are interested in this. So regarding the morale, like, you know, one thing that has helped is like forums to like a small degree, because it's super isolating out in these areas. But even just having these forums where the farmers can talk about how they're using the product, or that, you know, people enjoy that kind of aspect. Maybe one day we'll have inbuilt chats and stuff like that. But yeah, big roadmap.
Back to weather, just the background, our company prices weather, and we sell that as a SaaS service to insurance companies, so they can still offer weather insurance to farmers and other people who are affected by weather, which is everybody except worms in the Mariana Trench, who are affected 300 years later. We going back to what you're talking about there, we have a problem with Western Australia where the bomb data and the cleaned up silo data can be 7 or 8 degrees off from the actual ground data. And have you encountered this? Has anybody else in the audience encountered this, and have they found a way to solve it apart from trying to get access to the deeper data?
Yeah, so we haven't done too much on the temperature side. We've been focused on the rainfall itself. We will be adding temperature and like full weather station integration at some point. At the moment, all the integration for the weather side is on the rainfall, so that's what we use to evaluate. There were areas that did suffer worse, but that was like more the Northern Territory, where when it rains, it really rains. So if you miss it, the areas look terrible. Yeah, but overall, the silo was pretty okay for rain for us, for our regional spots that we were looking at. But silo is like an API that the Queensland government wrapped around bomb data, and they cleaned it up.
Sorry, I have a question. I didn't exactly capture whether you quantify and track carbon emissions along the supply chain. If so, would you mind elaborating on that?
Yeah, sure. So for the scope 3, they need to understand all the emissions of everything in their supply chain. So all these supply chains that are getting food from farms, they need to understand the impact on the farms. So for that, there's some generalized calculators that have been made with the University of Melbourne, and it's called a SB GAF. There's a GAF tool, so the SB for sheep beef GAF. So it's basically a big Excel spreadsheet where you type in a bunch of numbers, and it will spit out what the emissions are. And that's like the gold standard at the moment of how to calculate the emissions. And it does full farm emissions. It handles like diesels and petrol and electricity and all that as well. So we'll be integrating with that for starters, but it's also very problematic as well in that we have a whole lot of high resolution data. We don't just have to say this number of animals for the full year and they ate this pasture. We know it was, this many animals of this age class were in this paddock on this food type, then they moved to this paddock. So we can do this temporal analysis that's much more accurate. That's not as broad. So that's what we'll be pushing with Flint Pro, that other third party. That's for the emissions. And the sequestration, I believe it's coming from this source called the national accounts. It's what the government use for determining how much is growing. So for vegetation, it's quite a relatively easy, straightforward calculation once you identify the vegetation type. So we work with Flint Pro to give us that number.
Give us some time for networking. 2 more questions.
Yeah, I've already asked one, but you said you're only 25% of the market, which seems quite small. I mean, have you got a lot of competitors, or what's the? I mean, is it a popular thing to get into? Like,
our competitor is the pen and paper. Yeah, no, we're the market leader, by a long way. Yeah, so it is relatively new thing, right? So it's the last 8 years, like we were the first one really on mobile 8 years ago, right? That's what meant livestock was left behind. The smartphone out 2007 or 8, and then we were on 2014. the farmers are, they're all using Facebook. They know the rest of the world's moving on, and they're going, "Where's our app?"
Yeah.
So
Last question.
Bit of a silly question. How do you measure the efficacy of the platform in relation to the pen and paper?
yeah, that's a good question. One the sales guys would love to know the answer to. For other companies like IoT companies, it's you can see the profit, right? Because you've set up this thing, you're saving your time going out there and coming back to see the level, which you were doing in the past, right? But for Agriweb, what the value is they are actually recording all this anyway, and this is making it easy to use. So you're thinking about the time you're saving and all that communication. When the notebook goes through the wash, you've lost 3 months of data forever. You're talking about succession planning, right? The farmer's been doing this for decades. How do they tell everything to whoever's taking over the farm? So you're talking about the digital record keeping for being able to analyze your farm as well. You saw that individual animal growth there. Like that's very powerful in itself. Going into the weeds a bit, imagine you have some sheep that had offspring, okay? They might be spread over a 6-week period, which they call, 6-week drop. As you're bringing them to weigh, you want to be able to keep your heavier ones and get rid of your light ones, or move your light ones to a different area if they're not performing. But how do you know that when it's a 6-week gap, right? So that's why you really need this historical understanding of you're growing really well. You're just really young, to be able to make those decisions on the fly.
That's it for the questions. Unfortunately, just to give us some time to network. And it's when you network that you have a chance to ask more questions of Kenny and of Sphere. So can you please join me in thanking Kenny for a terrific. Before we go, just a few announcements.
If I could just make a 1-minute announcement. If anybody knows any good weather data scientists, I've been looking at CVs today. I spent the last 2 days looking at typhoon data sets, and I don't really like it very much. Talk to me.
So yeah, that jumped the gun there, but now is the time where anybody with an announcement, particularly around jobs or anything else they'd like to announce that's data science related, please come and make your announcement. Usually recruiters like to get up and present. Do we have any recruiters in the audience today? Well, there's usually here. Okay, so failing the announcements, just close proceedings. I'll remind you again that we got the data science employment forum coming up with a panel of senior people in like head of data and CTO and director of a very successful startup, several very successful startups, about their experiences of working, hiring data scientists. I'd also like to hear from you. You have something you would like to present to Data Science Sydney. I'd also like to hear from you if you have any ideas for what you want Data Science Sydney to be doing other than just running presentations. I think the presentations are great. At the moment, we've got these presentations. We've also got the occasional panel discussions. We want to do a lot more. Otherwise, is start an internship program like the one that Data Science Melbourne runs. We're about to do that, and then COVID struck. I'd like to get that going as well. Anybody who'd like to participate in that as something other than an intern, please get in touch with me. The interns will get their chance soon enough as well. So thank you all very much, and let's use the time remaining to network.